Welcome to ERC Tipsnology. In this video, I will be showing you how to use the multisim in creating 4 resistors in series parallel with 2 voltage sources, and the 2 voltage sources has different polarities direction. So let's start by creating the circuit, and using multisim here, I will place or put 4 resistors. Let's click on the basic followed by resistor and click OK. And you do this again, click OK for the second resistor, another OK for the third, and another OK for the fourth resistor. After that, we can click on the basic again and let's look for the sources, in particular the power sources, and let's put a ground first, and then let's click on DC power. Let's put one here and another OK, and that would be 2, and close. After that, let's rotate the second one. Let's flip it vertically, and the first voltage source, let's select the label and change it to VS1. And of course, the second one, V2, let's change its name to VS2. And then for the resistor, let's put here 10 ohms. And then for R2, let's make it, let's say 200. R3, let's make it 300. And R4, let's make the R4 400 later on. But let me just change the voltage source 1 to 10 volts and voltage source 2 to 20 volts. And the R4, let's make it 400 ohms. And then let's rotate the R2 counterclockwise or clockwise, but it will be vertical. And let's connect VS1 to R1, R1 to R3, R3 to VS2, VS2 to R4, and R4 connected to the negative side of the VS1, R2 between R1 and R3, let's move it a little up, and R2 connected at the bottom. And then after that, let's put a multimeter here in the middle and connect the positive between R1 and R3, and the negative will be connected at the bottom, and this will be measuring the voltage between R1 and R2 and R3 as the positive. And then let's put the ground at the bottom also. Remember, the ground will have 0 volts. And then let's double click XMM1 and run. We will get 9.128 volts across R2, or if this is nodal analysis, it's like the VA or the voltage node VA. Let's stop running the system and let's see. Let me choose one probe here. Let's choose the ammeter probe. Double click this. In the previous video, I already explained how to change the color or the font size of the probes. So let's say we want to make it red, and of course customize it so that it will only display the DC current. You may watch the previous videos that we have shown here to do it, and then run. You will get 87.2 milliamperes flowing through R1. Now let me fix the ammeter again, and let's hide the name PR1. Let's hide it and click OK. Apply so that the PR1 name, probe 1, will not be shown. We may also copy this and paste it here so that we will no longer change the font again. So right click the ammeter and then copy, or what I did here is I flipped it to the other side so that it can be readable. Also, this one you can drag. That's the third, and then let's run it, and it will display the current 87.2, 45.6 milliampere and 41.6 milliamperes coming from the VA, or at the top between R1 and R3. Now let me paste again also here on the left side of R1 just to prove to you that they will have the same current. R1 is in series with VS1, therefore it will have the same current. Let's copy paste again and let's put it down over here at the bottom of VS1, and you will see that the value of the current is still 87.2, although there will be a negative sign at the current at the bottom, and it has something to do with the direction of the current. If the direction that we assume is left to right and it's right to left, then it will be negative. So let's also take all the currents before R3, between R3 and VS2, and between VS2 and R4, and of course between R4 and the ground. Of course, R3 and R4 will have the same magnitude or value of 41.6 milliamperes, except the current flowing through R2, which is 45.6 milliamperes. And the voltage across or between R1 and R3 is XMM1, that's 9.128 volts. So this is how we can measure the currents through each of the resistors, but let me delete all of the current meter or the ammeters, and let me fix this resistor, move it a little to the right, and the R3, let's move it a little here in the middle, and let's get another meter. This time I will not use the probe, I will use the multimeter again, and double click it and move or click on A so that it will be a multimeter, and let's flip the multimeter number 2 so that the positive will be on the right side and the negative will be on the left side. So I cut the wire between R1 and R3, or before R2 and R3, just to get the current. Remember, we cut the wire or we disconnect the wire, and then we put the ammeter one on one side and the other negative on the other side. So let's paste, or we can copy paste the component or the device. So I put here positive and I put on the R2 negative, and double click it and drag the value here. So that's XMM3. Let's make it A. Make sure it's A for ammeter, and let's paste another current meter here or multimeter and remove the wire between the R1 and R3 over here, and positive on the middle or the junction of R1, 2, 3, and negative on the R3. And this will represent the current flowing through R3. Later on, when we run it, we will see the values of these currents, which would be similar with the way it is done in the probes for the measurement. Now let's move on and let's try to change the appearance of the multimeters. So all the negative probes of the or wires of the multimeter, I'm making it black. So now we have four uh, multimeters: XMM1, 2, 3, and 4. And when you double click it, it will display the values of the multimeter and also the control. You may change it if you want A, ammeter, V, voltmeter, ohm, ohmmeter, and DC or dB, I mean decibel. Now let's see the next step that we will do. As you can see here, we have run the system, and I was able to measure the voltages of XMM2, XMM3, and XMM4. So that's the measurements that we got. I forgot the XMM1, which is 9.128 volts. And that's it. You will see all of the currents, the three currents coming from the junction of R1 to R1, R2, and R3. Let's put another another meter. Let's paste two more meters and cut this wire, and let's put it over here again on R3, and the positive and the negative will be on the VS2. This is assuming that the direction of the current is from the intersection of R1, 2, 3 and going to the right side of R3. And at the bottom, we may put another meter here to measure the current. Positive on the positive side of the VS2 and negative on the R4, the other end of R4. But take note that we are expecting the same or similar, exactly the same values of currents on XMM4, XMM5, and XMM6, which are the three ammeters which are measuring the current flowing through the R3, VS2, and R4. And of course, that would be the same when we run this. Now let's put another multimeter between VS1 and R1 just to prove to you that the current flowing on VS1 and R1 are the same. So the positive on the R1 and the negative on the VS1. And let's paste another one finally at the bottom of VS1, between VS1 downside and R2. So let's cut this wire, put positive over here and put negative on the R2. So here we are assuming that the direction of the current will be from the negative, from this one, XMM8. And so we are expecting, of course, that the multimeter 2, 7, and 8 will have the same value or magnitude of the currents when we run the system. But let me fix this. And I hope you're not confused with too much multimeters I'm using here. But you see, if you double click the meter, it will either cancel or display, hide or display the values, the value of the meter and the function. If it will be an ammeter or V voltmeter, this is what we will be seeing. So when we run the system, it will give us the currents, which is exactly the same with what we have before using the probes. Now, the negative currents would only mean that the assumed direction that we have chosen is opposite. That's the reason for that. Now, let's stop running this system and let's change R1 to 100 ohms. So when you run it, it will also change all the values of the meters, because this is like what you see is what you get, or what you put here will be what you will be getting immediately when you run the system. There's no delay. So here, let's remove the display so that we can, the display of the values of the meters. So again, I have told you that even if you remove the display for the meters, when you double click it, it will display again. Double click one of the meters and it will display the measured values. Now let me just fix this by clicking on XMM1, that's for the voltage. If we are doing node, that will be like node VA. And then here, XMM2, this is the current flowing through R1. And it's negative because the assumed direction that we have is from right to left, but it seems like it will be from left to right because the answer is negative 56.522. So the negative means we have to reconsider changing the direction of the current in our final answers. So here we have to double click XMM5, double click XMM6 just to check if it is displaying the voltage properly. So XMM2, yes, it's there. Number 3 is there. Number 4 is there. And Let me just fix the multimeter number 2. This is number 2. That's what we are getting. This is number 7, number 8, number 4, number 5, number 6, and what else? 2, 4, 6, 7. Number 1, of course, 8, 2, 4, 6, 8. So, we have 2, 4, 6. We have 8 multimeters over here that we are trying to calculate the value of. And let me see. Let's delete the ammeters now, and let's put again or put back the circuit without the meters, because maybe you will find it confusing if you put too much multimeters there. So those two which you don't need, you may hide it by clicking it and then hide. But for this one, I did not delete all, but let me delete that one. Okay, R2 is there now. Let's delete the negative side of the XMM1, and delete 4 and number 5, and let's connect again or reconnect R3, R1, and R2, and R3 connected to VS2 and R4 connected to also to VS2. So we got the same original circuit that we had before, and let me just make it red, because I cannot stand looking at the two reds. And the negative, let's make it black and put it across R2. Okay, make it black. All right. And then you will be like measuring the voltage across R2, which is 200 ohms R2. So when you double click the XMM1, it will display the voltage of that node, which we will assume to be like node VA. So now what I'm doing is I'm just replacing, or I'm just placing some ammeter across all the 4 resistors that we have here. So, and then run it after putting the voltmeter across or in parallel with the resistors. Now I'm doing the ammeter or voltmeter across the R3. So this is R3, and the multimeter number 3, in terms of doing this, you have to consider changing the color of the negative side of the multimeter by making it black, which is what we usually do in the laboratory. If you will be doing this in the lab and you want to create your DMM or DC power supply, it must follow the correct way, which is the positive connected to, or the color of the positive in our DMM is even red, and the negative is black. That's what we have done here. So now we have 4 multimeters connected across or in parallel to the R1, R2, R3, and R4. And now let's double click everyone or all of the meters from XMM1, 2, 3, and 4. And let's put or position the boxes in the correct portion of the screen. But I have a plan of doing another measurement, but this time at this time we will just reserve it for in some other time. So right now we have shown you how to measure the voltages and currents, and this will be the end of this video tutorial. So I hope you learned something about it and you practice more in order to be able to draw a circuit using multisim. Thank you so much and have a nice day, everyone, and I hope that you will subscribe to our YouTube channel of ERC Tips Technology. So have a nice day and bye-bye.